So next example, we have a three-phase four-wire line with phase voltage of 120 VRMS and positive sequence applies a load as shown in the figure. So we have a motor load, a three-phase motor, and we have lighting loads which are connected to each phase. So we have phase A, phase B, phase C, and D here is just our neutral. So a 24 kilowatt lighting load is connected at phase A and the neutral line. A 15 kilowatt load is connected between phase B and the neutral line, and a 9 kilowatt load is connected between line C and the neutral line. So if 3 wattmeters are arranged to measure the power in each line, calculate the reading of each meter. Next is calculate the magnitude of the current in the neutral line. So if we are to measure the power in each line, so we must connect 3 wattmeters to each phase. We have meter 1, then meter 2, we have wattmeter 3. So where do we connect the common line? So we connect it to the neutral line. For wattmeter 1, the measured voltage is VAN. VAN. And then we have the current. So let's label the currents flowing through here. So let's label this as I1, we have I2, then we have I3. So for wattmeter 1, we have VAN, I1, cosine of theta of AN minus theta of current I1. And for meter 2, stage VBN, current I2, cosine of theta PN minus theta of current I2. Now for wattmeter 3, we have PN I3 cosine of theta N minus theta of I3. So we need to get the values of I1, I2, then I3. So how do we get the currents I1, I2, and I3? So first, let's get the currents at the motor and of the lighting loads. Let's label this current here as current IAM, this IBM, ICM. Then we have I and M. Let's label this current the 9 kilowatt lighting load as IEL, current right here as IL, and then we have IAL. Let's label this as node A, node B. Now performing KCL each node, we have KCL at A, we have I1 equivalent to IAL plus IAM. KCL at B, we have equivalent to IBL plus IM. And for I3, we have ICL plus I. Next, let's list our given values. Now, since we are given the total apparent power for the motor load, the PF, we can get the total complex power. Total complex power is just 260 with angle of positive 31.79 degrees kVA. Now, when we have the total complex power, remember that our total complex power is equivalent to C times the V phase times the conjugate of the I phase. Now, since we can treat a balanced three-phase motor as a balanced Y load, so this will become V times, so let's consider the phase voltage VAN. Yep. VAN, and you have the current IAM. So we have this value, we can now get IAM. IAM equivalent to over VAN, we have conjugate equivalent to have angle of 9.9 over 3 times 120 to 0. So IAM equivalent to 100 point angle of 31. We have the value of IAM, and I get the values of IBM and ICM. We have the value of IAM, and I get the values of IBM and ICM. IBM and of 51, ICM equivalent 100. Point. Next, we can get the currents of the lighting loads. The equation S equals to Dp, the conjugate of Ip. For IAL, we have 4K over 120 conjugate equivalent to 200 angle 0. For IBL, we have 10K over 120 angle negative 120 to 5 angle of negative. ICL equivalent to 9K over 120 angle of 120 55 angle years. So notice the currents, the lighting loads are in phase with its phase voltages. So we have VAN, VBN. Since they are really resistive lo loads, V and voltage and the current are in phase. The next, we can now get the values of I1, I2, and I3. So I1 is just IAL plus IAM. I2 is IBL plus IBM, and I3 is just ICL, ICM. So I1 is equivalent to, we have 898.42 angle of 35 point. For I2, we have 831.28 angle negative 147. For I3, we have 786.96 angle 31.09. So having these values, you can now get the wattmeter readings of meter 1, 2, and 3. Meter 1, the VAN, I, I1, cosine of theta AN, theta I1. So wattmeter 1 is equivalent to 97.37 watts. For wattmeter 2, the VBN I2 sine of theta minus theta of I2. We have 88.67 watts. Now for wattmeter 3, we have VCN I3 cosine of theta VCN minus theta of 3. We have 82.67 kilowatts. Next question is, calculate the magnitude of the current in the neutral line. So if you apply KCL at node N, IN equivalent to sum of the lighting load currents. We have IAL plus IBL plus ICL equivalent to, have 108.97 angle of negative 3 point. There's another way to solve for the readings for wattmeter 1, wattmeter 2, wattmeter 3. So if you take a look at motor load, we're given the apparent power and the PF. So we can also get the uh, total power, where the total power of the motor is equivalent to 160 times cosine of theta. So we have 221 kilowatts. So the power per phase of the motor is 221 divided by 4 equivalent to 73.67 kilowatts. Now if you add this value right here with each of the power of the lighting load, the lighting load connected at Pn, we add this 7 kilowatts for load Bn, lighting load Bn, 0.67 plus we can get the total real power at phase. Now for phase A, we have 4 plus 7. We have 97.67 watts. For phase B, in that plus 73.67, we have 88.7 kilowatts plus 9 kilowatts plus 73.62 kilowatts, which is the same this right here.